I want to, first priority today, get our few leftover notes finished from yesterday. If you recall yesterday we were talking in 4.1 about degrees and radians, DMS, degrees minutes second, right? Do you remember the relationship to go from degrees to radians? Okay, there we go. Pi over 180. That's what I was looking for. So go from degrees to radians, it's multiplied by pi over 180. To go from radians to degrees, 180 over pi. And interesting enough, so yesterday I kind of started pointing at the unit circle a little bit. Like, for instance, when we found 90 degrees to be pi over 2. Kind of, does that make sense, right? So if you go from 0, which is there at the right, what is at where 180 would be? Pi. And what are we multiplying by? Pi over 180 or 180 over pi. So realize, what do we know about pi and 180? They are equivalent, yes? Okay, they're equivalent. So in a sense, you're multiplying by 1. It's just not really 1 because they're in two different forms. Okay, pi and 180 are equal. So, okay. We also started on the back side, we talked about our arc length formula. Arc length formula, S equals R theta. R, of course, is radius. Theta is the angle in radian forms, and we use that on the pizza problem, right? And S stands for arc length being a curved piece of the circle, right? Okay, so now we're going to look at the next example. The running lanes at the Emory-Sears track at Bluffton College are 1 meter wide. The inside radius of lane 1 is 33 meters, and the inside radius of lane 2 is 34 meters. How much longer is lane 2 than lane 1 around one turn? And so the picture that I think looks like a rainbow is what we're trying to figure out. That is one turn. Okay? So, what kind of pieces do you see here? What kind of things can we label? The running lanes are 1 meter wide. So what's that mean? This is 1 meter and they're each 1 meter wide, yes. The inside radius of lane 1 is 33 meters. Silly question, which one's lane 1? The inside, right? So, I'll label over here. This is lane 1. The farther out you go, the higher the lane numbers get, right? So lane 1's inside, you count out from there. So there's lane 1, there's lane 2. Radius. What do we mean radius? Where's the radius going to be here? Okay, so the middle, meaning the center point of the circle, right? The radius goes from the center point of the circle. And so I'm going to put the center point of my circle right here. So from here, and I'll draw it right there, out is going to be 33 meters. Because the inside radius of lane 1 is 33 meters. Inside radius of lane 2 is 34 meters. Which, is that logical to you guys? So from that center to the inside of lane 2, which is the border line between lane 1 and lane 2 is 34 meters, which, considering the lanes are 1 meter each, makes sense. Okay. We want to know how much longer is lane 2 than lane 1 around one turn. So if they have to stay their lanes, what's the difference in distance? What else do we, should I say it's obvious? What formula are they wanting us to use here? That S equals R theta, yes? Okay, and we're going to have to find the length of both lanes. So, if we talk lane 1, and we talk lane 2. We're using that formula in both cases. S equals R theta. What have we not talked about yet that we need to talk about? What do we not know for that formula? A degree, yes, a theta. We need to know an angle. So think about it. Here's the center of the circle. We're trying to find this partition, this distance. What degree are we talking about there? What? 180. Okay. We are talking about that straight line, that straight angle, so 180 degrees. Now, is 180 what I'm going to use in my formula? No, because my formula requires radian mode. You can't use degrees. So what is 180 in radians? Pi. Commit that to memory, guys. Okay, it's the one I just pointed out over there, right? Or if you're trying to convert, you take 180 and multiply by pi over 180. 180s cancel, and so it is just pi. So let's look at lane 1. S equals R, what was my radius for lane 1? 33 times theta, which is pi. Easiest way to say, what is 33 times pi? 33 pi. And I'm going to leave it that way for right now. What about lane 2? Lane 2? 34 times pi. Because on the inside radius on lane 2 is 34. It's still the same angle. And 34 times pi is 34 pi. What do we need to figure out? Much longer is lane 2 than lane 1, so what do we do? Subtract. We need to do lane 2 minus lane 1, which means I'm doing 34 pi minus 33 pi. What is 34 pi minus 33 pi? 1 pi. Now, it would make sense to not say that lane 2 is pi longer than lane 1. What do you guys know about pi? 3.14. So lane 2 is 3.14 what? Meters longer than lane 1. I mean, yes, pi is technically equivalent, but are you going to go out and tell someone that that lane is pi meters longer? If you want to be kind of math nerdy about it, maybe, but I'm guessing not what you're going to use. Okay. So the other problem that I did not get figured out or finished with the arc length. Let's talk about angular and linear motion here. I mentioned dimensional analysis yesterday, converting units, right? You've seen it in math along the way at some point. If you've had chemistry, you've used it in chemistry, but being able to convert those units, okay? We're going to use that here. Angular speed is measured in revolutions per minute. So when I say revolutions per minute, common abbreviation is RPM. If you have a dial in your car that talks about RPM, that is revolutions per minute. And we're going to look at how we can change that to linear speed, measured in units like miles per hour, maybe kilometers per hour, maybe meters per second, but some kind of conversion like that. You're going to use conversion factors like we use to change radians to degrees, like we used to go from degrees minutes to to degrees, that kind of thing. So the example we're looking at is Albert's truck has wheels 36 inches in diameter. If the wheels are rotating 630 RPM, so at that point they wrote rotations per minute. Rotations per minute, same idea as revolutions, right? A rotation or a revolution is all the same. Find the truck speed in miles per hour. So what do we have here? The wheels are 36 inches in diameter. The wheels are rotating at 630 RPM. And we're being asked to find miles per hour. Now, let's see. Debating where to start here, or how I want to start. I need to give you guys an added fact. And I'm going to write it right in here. Because in order to make this conversion happen, what did I do? Write that off the edge? Yep. In order to make this conversion happen, one of the things we're going to have to talk about as we're going through, a central angle. So like a central angle on a circle, right? That of 1 radian, a central angle of 1 radian will always intersect the circle at a length of the radius. So if you have a central angle that is 1 radian, right? That one little piece, it's going to intersect the arc the length of the radius. Okay, and that's, that's something you need to know. If I ask you guys, how many minutes in an hour, or seconds in an hour, those kind of things you can figure out, right? This is the other piece you'll need to know. And I'm going to write it right in here because we will forget. A central angle of 1 radian. Okay, so 1 radian intersects an arc, so talking about an arc on the circle, the length of the radius. Write that in somewhere, guys, because you will need that information. So 1 radian intersects the arc, the length of the radius. So what you need to get out of that is that 1 radian is going to equal whatever your radius is. Okay, so notice I have a fraction set up. I always set these up as fractions. 630 revolutions, or you could say rotations, per minute, and that means it's going to be per 1 minute, yes? What's my goal? My final goal is to end up at miles per hour. So that means revolutions has to become miles, and minutes has to become hours. Thank you. Okay, Daryl's going to take the easy one to get us started. Make minutes hours? Okay. Okay, so to make minutes into hours, we have to know the relationship that 60 minutes in an hour. You can either do 60 minutes over 1 hour or 1 hour over 60 minutes, but we want to set it up so that minutes will cancel, right? So 60 minutes over 1 hour. And if we look at that, what happens? Minutes will cancel. So if I just multiplied those two right now, I would have revolutions per hour. Okay, well, we've got one of our labels changed. Now, we somehow have to get from revolutions to miles. Okay. What do we mean revolution or rotation? What is a revolution or rotation? I see Logan back there doing this. Okay. So what is 1 revolution? 360 degrees. Now, let's not talk degrees. Let's talk radians. I know this is new to you. Trying to figure out based on looking at the circle. Once around that circle, if you start at 0 and you go back to 0, what are we ending at? 2 pi. Okay, so remember we already talked about that pi is 180, yes? So what's 2 pi then? 360. Okay? So, I'm going to use the idea that I'm going to go from revolutions to radians. I mean, you could go from revolutions to degrees, but then you have to turn around and go from degrees to radians. I'm just kind of skipping that step. So, revolutions over radians or radians over revolutions? Radians over revolution, because I already have revolutions on top, so I'm going to put revolutions on bottom. 1 revolution is 2 pi radians. Because once around a circle is 2 pi in radians, just like it's 360 degrees in degrees. So now my revolutions can cancel. And now I'm at radians. Okay? This is where we need to talk about the starred comment that I made. A central angle of 1 radian intersects an arc the length of the radius. So 1 radian is equal to the radius. What's my radius? 18? I never stated it, but logic says if our diameter is 36 inches, our radius is 18 inches. So, 1 radian on this particular problem is going to be equal to my radius of 18 inches. Inches over radians or radians over inches? Okay, I already have radians on top, so I'm now going to put radians on bottom. So 1 radian is equal to, in this case, 18 inches. Now we can cancel radians. And I just put that star there to represent that came from my starred comment. Okay, if we stopped right now, what would we be at? Inches per hour. So what do I have to do with inches? Okay, so and I was going to set up, in my brain I set up as 2 fractions. Inches, we know inches is what? What's the main connection, you know? How many inches? 12 and a foot. So I would have said 1 foot is 12 inches. Or, you know, Daryl was doing it all at once. That's fine too. And now I'm at feet. What do we know about feet? What are you supposed to know about feet? 1 mile is 5,280 feet. He already said it. He said it earlier. And so now, my feet cancel. Yes, that is just a good one to know. 1 mile is 5,280 feet. I'm not going to say I don't occasionally forget it, but it's just a really good one to know. Okay, so where are we at, guys? Are we at miles per hour? Have we reached our end? Yeah. You could do this different ways, but this is what I have. Now, grab your calculator. You have to know how to do this on the calculator. You have different options, but you have to have an option that works for you. Okay? A couple of different things. You could set up a fraction in your calculator. Okay? I like to think everything on top multiplies, yes? You can do multiply everything on top, multiply everything on bottom, and then take those 2 numbers and divide. Okay? You could do multiply everything on top and then just do divide by multiple things on bottom. You just have to be careful how you set it up. As I said, you could set up a fraction here. 630 times, which way did we set up this year? 60 times 2. Notice I'm going to use the pi, right? Times 18. And then on bottom, 12 times 5280. If you've done it correct, you get an answer like mine. You could do 630 times 60 times 2 pi times 18, and then you could go divide by 12, divide by 5280. You could do something like that. You could do 630 times 60 times 2 pi times 18, and then you can go divide by, and you can put in parentheses 12 times 5280, but that denominator would have to be in parentheses. Notice I got the same answer all three ways, right? There's also wrong ways to do it, so don't do it wrong. Did you figure out how you would do it? Okay, what's our answer? 67 point, if we go 2 decimal places, 47, and my label is miles per hour. I just wrote MI/HR. You could also write MPH for miles per hour. That is an acceptable abbreviation. Okay, guys. You know a lot of that stuff, yes? Know how to do those type of problems. Probably the hardest problem of the lesson, just because we'll forget the pieces. Okay, questions on this one? Okay, one last one. This is an easy one. Nautical mile. Okay, so a little connection here. A nautical mile is a length of 1 minute of arc along the Earth's equator. So we think nautical miles out when sailing, right? A statute mile is what we're used to when we talk about miles, what they call the familiar land mile. They give us two conversions between nautical and statute miles. They work almost the same. They're very similar. You can use the idea that 1 statute mile is 0.87 nautical miles, or 1 nautical mile is 1.15 statute miles. Okay, the example. Megan McCarty, a pilot for Western Airlines, frequently pilots flights from Boston to San Francisco, a distance of 2,698 statute miles. Her flight time calculations are based on nautical miles. How many nautical miles is it from Boston to San Francisco? So, what are you thinking? They gave me 2,698 statute miles. We're trying to get it to nautical miles. If you want, you can think in terms of a fraction. 2,698 statute miles over 1 times what fraction? And since we're going from statute miles, I would say use the one that has 1 statute mile. If we think like above, that means statute miles goes on bottom. So 1 statute mile is approximately 0.87 nautical miles. I don't know appropriate abbreviations for these, so I just kind of shorten them. So you can do 2,698 times 0.87. The other option would be 2,698, I think it's divided by 1.15. What do we get? So did you divide by 1.15? It's off a little bit more than I expected then. I thought it was a little bit closer than that, because I get 2347.26. Yeah, they're close, not exactly, which does mean, something like a quiz or a test, I'd have to be flexible there unless it specifies which one to use or if you're only given one. Okay. But similar. Okay. Your homework for this lesson. Did you guys already write it down? You should have. I'm writing it down right here. Is on page 325. Numbers 2 through 42 evens. What is it? 45, 50, and 51.